All right, so now what we're going to do is we're going to put everything all together. Okay, now if you notice I've used cos in here. However, you could use sine. They both work the same kind of idea. Now I've used the letters A, B, C, and D. For most part, that's what your textbook uses. It's not so important whether we're looking at A or B. It's the location of those letters that are important. So if I was asked to graph this, the first thing that I would do is I would look at the end, and that would be my vertical displacement. And I would put a dotted line through the y-axis at that location. The next thing I would look at would be the amplitude. And the amplitude I would put so many units up and so many units down from that vertical displacement dotted line. The next thing I would do, if it's in this form, is I would, first of all, multiply figure out my period, because remember B determines that, and multiply all those important values by the reciprocal of that. So that would be my third thing. And then after I had that, then the final thing that I would do in order to get my axes all done would be to look at my phase shift. Okay, so my phase shift is my C value. So my phase shift, I would either add, remember, going to always add the opposite. And finally, I would look to see whether I have sine, so I would start in the middle, or if I had cosine, I start at the highest location. Okay, so that would be the last item that I would look at. Now let's just take a look at what that means with just an example, and we'll forget about graphing it first of all. Okay, so first of all, when I look at this equation here, it says y equals cos bracket 2x minus 45. This is not in the same format as what you're seeing up here. So the first thing I would do on something like this is I have to change it so it's like this format. So the first thing I would do is I would actually divide out that 2. So I would have y equals cos 2 bracket x, and when I divide 45 by 2, I end up with 22.5. And that's all degrees. Okay, so let's take a look at what this would mean. So I would take my important values that I told you to memorize a long time ago, hopefully you have them, and I'm going to multiply by the reciprocal. So in this case, I'm going to be multiplying by 1/2, or dividing by 2, same difference. So that would be 0, 45, 90, 135, and then 180. The next thing that I would do is I would add or subtract the phase shift. Now in this question it's minus 45, so sorry, not that one, this one. It's minus 22.5, so I would add 22.5 to each one of these values here. So when we do that, you probably don't need that other column there. So when I add that, so I end up with 22.5, 45 plus 22.5, we're looking at 67.5, then 112.5. Oops, not paying attention to what I'm doing there. 112.5. 135 plus 22.5 will be 157.5. And finally, 180 would be 202.5. Now this would be very difficult for us to graph, right? Because we'd have to label our x-axis using those values. Now just to give you an idea of what this actually looks like if I took the graphing calculator, which I have done, and you can see here that I have entered both forms of the equation. I'm going to give that one away. So this is the one that we just did. So when I go to graph it, you can see it, and I'm just going to hit the trace, and I know you have to look kind of close to see what's going on there. But when I get to the top, which is at 1, notice it's 22.5, which is what we have. Then when I get to 0, I should get 67.5. So if we follow the trace and we're at 0, you can see it is 67.5. So we could keep doing that trace. Our lowest point would be -1, which we're at there. It's 112.5. So you get the same thing there. Now, notice that, remember, we divided out that 2 out of the what was going on with the angle. Now, if I actually took and put this equation into the calculator, you would see that you get the exact same thing. So that would be 2x minus 45. And I know when I do this, I don't see any difference. That's because it's on top of it. If I do trace again, you'll notice that we will get the same amount too. At 1, it's 22.5. So you get the same answer. The only thing is it's much harder to graph this one compared to this one. Okay, so now what we're going to do is we're going to go and actually do some questions. Okay, so the first one they're asking us to do is graph the following. Y equals 3 cos 1/2. There is a bracket here, x plus 45 minus 1. Okay, so the first thing that I need to do is I need to make an x and y axis. Okay, so I'm going to do that first. And we'll obviously make it that. And I know that I'm going to be going to the left, so I want to make sure that I give myself some room to do that. And I'm just going to go here, and I'm going to go across here. Okay, so there's my x and y. And I can actually add a few numbers to my y. So there's 1, here's -2, -4. Okay, so remember I'm after as many marks as possible. So I'm going to start at the end, which says a -1. So I'm going to put a dotted line there. And we might as well have some color in our life here. So I do that at -1. So the graph is that's middle. The amplitude is 3, so I have to go up 3 from that and down 3. Okay, so what I've done here is I've made sure that I was getting some marks for the question. The next thing I have to do is I have to figure out how I'm going to label my axis. Now remember from the previous example, this one here, we took this kind of chart. We didn't need the whole thing, but I think we'll copy it and we'll bring it over here just to make my life easier. It doesn't necessarily make yours. Okay, I'm just going to make it smaller. We don't need it really, really large. And the first thing I'm going to do is my reciprocal of 1/2 is 2. So I'm going to multiply all these values by 2. And when I do that, actually I don't like this at all, so it's going to disappear. I'm going to take and actually make, not a circle. I'm sure you're having fun watching me do all this. I'm going to make a rectangle, and I'm actually going to fill it in so that I have a white spot. Hopefully. I don't want a screen. I will just want this. There we go, properties. And I'm going to make it a solid fill, and we'll make it white. There we go. So we would take our values, our important values, which were, now that you watched me play around, our important values that we started with were 0, 90, 180, 270, and 360. We need to multiply them by the reciprocal of 1/2, which is 2. So we're going to multiply everything by 2. So when we do that, we end up with 0, 180, 360, 540, and then 720. Okay, so no problem there. Then we need to add or subtract the phase shift. This time the phase shift is +45, which means I'm going to the left. So I'm going to subtract 45 from each one of these. So I'm really starting at -45. So So here we end up with 135. We end up with 315. We end up with 495. Hopefully I'm not making a subtraction error. 700, so we're looking at 600. Come on, pen. 600 and that's my calculator in my brain working actually. 45, 85. Okay, so hopefully I have those correct. Okay, so now these are where my important values occur. My problem is how on earth do I put them on here this time? Okay, because if I start at negative 45, or at 45, means that every single one of these dots stands for 45. And I have to get up to 685. So if I even look at that, 685 divided by 45, I would need 15 ticks. I don't think I have 15 ticks. I have 1, 2, 3, 4, 5, 8, 9, 10, 11, 12. Even if I started over there, I still wouldn't have enough. So what first thing I'm going to do is I'm going to have to add some more ticks to my graph. So I'm going to put one in between each one of these so that that will increase the number that I have across. Okay, so you just can't decide that the first tick is 45 and the next tick is 135. It just doesn't work that way. You know that from graphing. So each tick is going to be worth 45. And so that's the first thing I have to do. So I would do it in purple and make it small. And so that means I would have start with negative 45. Come here. Negative 45. That means this would be positive 45. The next one would be 90. The next one would be 135. Now this is what I usually do. So how many spaces are there in between my two important values, which were here and here? Well, there's 1, 2, 3, 4. So every fourth dot. So 1, 1, 2, 3, 4. So 1, 2, 3, 4. So this would be 315. 1, 2, 3, 4. This one here would be 495. Oops. And then 1, 2, 3, 4. This one here would be 685. Okay. And if I can get a 5 to go. Okay, so it's more of a challenge when something's been stretched, has been expanded rather than compressed. All right, so now I need to do is, so we have our axes labeled and I'm have to look at cos. Cos starts at the highest point, so that's what we're going to do. So cos is at the highest point. Come here, there we go. So the highest point, and it's going to be at negative 45. The next spot would be at 135, which would be here. The next is at 135, which would be at the bottom. And then we're up to the middle again at 495, and then back at the top to complete one period. Okay, so you can see that it's a little more challenging only in the respect of getting the axes labeled. Okay, now next year when you take this, working with trigonometry and the graphs, you're not going to be in degrees, you're going to be in radians. And so the challenge there also will be on the x-axis, but more so dealing with fractions. Okay, so the next little part that I have, which I'm just going to pause because I'm just going to go back and forth between here. So I'm going to stop this for a second. Okay, so the first thing if I look at if I want to state the period, I can do it a couple different ways. I can either read it from our table that we created, so 720, or I can actually do 360 divided by 1/2. Same thing with the domain and range. I just read my graph.